I'm Amberly. Come on in, have a seat, get comfortable, because today I'm going to be teaching you about variables, what they are, why they're called that, and how we use them in programming. Let's take a minute to think about all of the programs and apps that we use in our daily lives and all the data that has to be involved with that. Your Grubhub order, the weather app, GPS. On the other side of that screen is a program that's storing all of that information that you're using in variables. Say that your friend got a new phone number, so you update their number in your contacts list. What you're actually updating is the information stored within the variable that manages your friend's phone number. If we take a minute to think about it, we are storing, accessing, and changing data all the time. You can think of variables as containers that store little pieces of information. As developers, it's our job to create those variables and manages what information gets stored and which ones. By the end of this video, you'll have an understanding of what variables are, how we use them, and the terminology that we use when working with them. Let's get to it. For today's example, we're going to build a program for a doctor's office that tracks the name, age in years, and weight in pounds of all the patients. Since we have 3 pieces of information, that means we're going to need 3 variables, and I've listed them here for us. Now, let's say that our patient's name is Patrick. And let's say Patrick is 35 years old, and he weighs a nice American 224.6. All right, now looking at this data that we've got here, would you say that this is pretty much all the same? As humans, we don't really distinguish between different types of data. We don't think, oh, that's a number with a decimal, that's a whole number, and this is made up of letters. But computers, that's exactly how they think. And as developers, we need to meet the computers on their level, and we need to indicate to our program what type of information each of these variables is going to be. Data is typically classified into these 5 data types. First, we'll start with doubles and floats. This is a numerical data that extends beyond the decimal point. For example, the number pi, 3.14. Another numerical data type is an int, which is short for integer. If you haven't mathed in a while, an integer is a whole number, so no decimal, remainder, or fractions. In fact, if you try to store a double value in an int, any value beyond the decimal place gets cut off. This is called truncation, and it can be a very real problem. For example, if a patient has to take 1.5 milligrams of a life-saving medication, but we stored that dosage in an int variable, that patient is only going to see to take 1 milligram because the 0.5 is going to be truncated. They would be missing 33% of their dosage, and that could be pretty serious, right? Next we have char, which is short for character. This type of variable would store a single letter like Y or N or T. And along that same line, next up we have strings, which are also composed of letters. The difference between a string and a char is that a char is a single character, whereas a string is a string of characters strung together. As you can see here, the letter T is a char, but if it were 2, it would be a string because there are at least 2 characters. This is a good time to mention that the values stored within char and string variables must be enclosed in quotes. Char values get a single quote, and string values get a double quote. This ties in nicely with how we remember the difference between chars and strings. Chars are a single character, so they get a single quote. Strings are at least 2 characters, so they get double quotes. We'll talk more about this in a bit. Finally, the last data type, and actually my personal favorite, is bool. Bool is short for Boolean, and it can only store one of 2 values, true or false. Now, all of these data types work independently of one another, but there is one last pseudo data type, which is placed as a prefix to the data types that we've talked about so far. This pseudo type is called Const. You can think of Const as being kind of like Mr. or Ms. as it goes in front. Unlike a standard variable, which the value can change, Const indicates that the value in that particular variable will remain constant. It can't change. Now that we know about the 5 major data types, let's apply them to the variables that we have here. What data type do you think would be most appropriate for name? It's going to be a string, right? Because we have text. So we'll just write that over here. What about age? This is going to be a nice round number, right? So that would probably be an int. And then, of course, last but not least, we've got weight, which is going to have decimal value past it. So what would we want to make that? A double. All right, awesome. Now, you all know I'm passionate about forming good habits before you form bad ones. So what we have right here is the opportunity to form a good habit and learn about naming conventions. So right now we have 3 variables. We've got our string with name, our int for age, and our double for weight. This is pretty much exactly what we're going to type into Visual Studio, but we can't do that until we make one tiny but critical correction. As it's written now, we are breaking a major rule by not following C++'s naming convention for variables.
A naming convention is a set of rules that sets the standard for how something should be named.
Every programming language has its own naming conventions, and as your skills advance, you'll find that there are naming conventions for almost all aspects of programming, not just variables. Since we're coding in C++, we will be naming our variables according to the camel casing convention. Camel casing is when the first word in a variable name is lowercase, with every following word being capitalized. As you can see, this makes a nice camel hump, which is why we call it camel casing. Now that we know that, let's name our variables properly. All right, so to make these camel casing appropriate, we need to have our first word being lowercase. Instead of just changing these, I'm going to go ahead and add patient in front of them, because that way they're also named a little more descriptively. So we'll turn this into patient name, patient age, and patient weight. And now we have a nice little camel hump on our variable names. Perfect. You can tell a lot about a variable based on the way it's named. For example, if we had a constant variable, its name would be in all capital letters with individual words being separated by an underscore. This way, if I'm on like line 500 of a program and I see visit cost, I know just by the way that it's named that that variable is a constant and I won't be able to change its value. This saves me from having to scroll all the way back up to the top of the page to check. Okay, so our variables have data types, they're properly named, and we know their values. Along with naming conventions, another good habit to form is learning to use the proper terminology when you're working with variables. Those terms are data type, declaring, initializing, calling, and value. I'm going to demonstrate these terms to you now. So we're going to represent our 3 variables, and as you remember, declaring a variable is like RSVPing to a party. We're letting the host, or in this case the computer, know who is coming so that some space can be set aside for them. If you don't RSVP to a wedding, there's not going to be a seat for you when you get there. If we don't declare our variables, we're not going to have any computer memory set aside to store values in. So to declare a variable, all we have to do is tell the compiler the data type of that variable and what we want to name it. So this is the data type. Okay, that's one of our terms. And we just say, this is what type it's going to be, and here's how I want to refer to it. That's it, just the data type and name. Next we have initialize. Initializing is when a variable is given a value by setting it equal to something. The value of a variable is the literal data that it is storing. So right now our jars are empty because these variables have just been declared. They haven't been initialized. And this is usually how it goes with variables. In this case, for our example program, we know the values of these variables, so we can go ahead and initialize them. But in most cases, we won't be this lucky. And the variables are going to be initialized by getting information from the user, and I'll be showing you how to do that in one of our next videos. So the very last way we interact with a variable is by calling one. So when we call a variable, we're calling it by its name in order to retrieve its value. It kind of looks like this. Patient name. When we call a variable by its name, the computer returns the value that's being stored within that variable. Then we can use it for a calculation, a report, display it to the user, whatever we want. So those are the main ways that we interact with variables as programmers. But how do we take this analog illustration of the process into the digital world of C++? To find out, stick around and watch the next video. We're going to be coding out this entire process in Visual Studio. Trust me, folks, there is no better way to learn something than by actually doing it. I'll see you there.